All right, question 2. This is the Simply Bagels Bakery problem. If you look at the information given to us in the problem, it says that the bakery relies on an application for handling its orders. The designer of the application started the project by defining an interface called order item, and they give that in the problem description. If you look, it's an interface, which means it's just sort of like the contract to say if anything is going to be an order item, it has to explain what these three methods do. It has to define a method called getPrice, a method called getQuantity, and a method called getCost, and then actually tell you what to do with those. It says, then the designer wrote a class called Bagels Order Item to implement that order item interface, and then a class Baker's Dozen, which is a subclass of the Bagels Order Item. And then they give a class diagram showing how that works. So part A of this question is going to ask us to create the Bagels Order Item class. It asks us to write it that implements the interface for order item, and then we want to implement it in accordance with the encapsulation principle, provide one constructor that takes in a price and quantity, and then provide access to methods for those price and quantity. Finally, we want a getCost method that should return the price times the quantity, and then it tells us to write that entire class. So we're going to start out by defining this class called Bagels Order Item. Oops. And since it is implementing an interface, we have to include that in our class header. Use the keyword implements and then the name of your interface, which is order item. So underneath that, we want to go ahead and define our instance variables. What are the properties of a Bagels order item? What are its characteristics? Well, it has a price and it has a quantity. When someone makes an order, that order has a cost and then a quantity. How many bagels are they actually ordering? So to use that principle of encapsulation, we're going to make both of these private, and price is going to be a double value since we could have dollars and cents, and then the quantity, that's going to be a whole value, so no one can buy like a decimal part or a fractional part of a bagel. So those are our properties. Now we want to build our constructor. Remember, constructor just has the identical name as the class. So in this case, we'll say public Bagels Order Item. And whoops, didn't mean to close that off there. So when we are using the constructor, remember your constructor needs to take in two properties and actually set these values. So they gave us double price. We can change the name just a little bit. We change it to my price. And to show you, there are two ways to do this. So technically I could change the name or I could use the identical name. So I'm going to show you both methods here. Okay, normally you would pick one of these two methods and use it for all of your variables for your constructor. But I want to show you again just the two strategies here. Normally throughout the year we've been just changing the name of the value. And then when we get inside to set the value of the price, we just say price equals my price, right? But you technically can use the identical name as the variable you're looking at. However, if I go to write quantity, which is what we're calling it up here, equals quantity here, how does the code know which one we're talking about? Like, does the top of the original one equal the new one, or does the new one equal the original? How do we know which one is being set? The way this works is if you want to set the variable for your entire class, the actual instance variable, if it has the same name, you would say this dot quantity, which means this bagel order item, take its quantity, which is stored up here, and set it equal to the quantity that's being passed in. So this notation is common in programming. However, some people like to change the variables and use the notation we've seen throughout the year. Most of the time on the exam, you'll see this notation, but this is acceptable as well. So I just want to show you that there were two options for how you go about using your variables and writing them here. If you want to use the exact names that you have up here, just include this dot before the name of the variable you're setting. So If I was to change this to say double price, then I would say this dot price equals price. And then that would establish the same principle we saw before. So it would actually set these two properties equal to the parameters that are being passed in. So again, just a couple different options you have there. Change the name or keep it the same and use the this dot notation to set your instance variables. So there's the constructor. Now we want to include our two accessor methods. We'll do those two really quick. So we're going to have public get price, which is going to return the price as a double. So that method, really simply, we just want to return price, whatever is stored in that instance variable. Okay, since I'm in the same class, I have access to that private variable. Same thing for quantity. Quantity is going to return an integer, and we call get quantity. So I'll say public int get quantity. Again, it's a method, so use your parentheses. Now notice I didn't say anything there, but you can, if it's just one line of code, you are more than welcome to just fit it on the same line as your brace. This you actually will probably see on the test anytime there's code given to you. If it's one line of code in a method, they'll usually define this just on one line and put a brace at the front and a brace at the end. It accomplishes the same purpose as opening a brace, going down a line, writing one line of code, and then closing it off. It works the same way. This is just more common if you have just one line. And then finally, we need a get cost method. Remember, since we implemented the order item interface, we have to include all of the three methods defined. We've already included the first two, get price and get quantity. Now I need get cost. I'm kind of running out of room here, so what I'm going to do is, as opposed to messing with the window here, I'm going to write this out to the side and then just draw an arrow. Obviously, on the actual test, you would have room to write your code. So how do we get the cost? It actually told us in the method, but we could probably figure this out on our own. The price is the price of each bagel. Quantity is how many, so the cost of the entire order is going to be the price times the quantity. So we just want to, we can actually do this all in one line. We want to multiply price times quantity. Since price is already a double, that means the result is going to be a double. We're going to multiply double times an int, we get a double. So we want to multiply those together and then return that value all at once. So we can include it on one line. So I would include this underneath here, and then we would close out the entire class file. So we have our instance variables encapsulated, making them private. We have our constructor, and then the three methods that we were required to implement since we implemented that order item interface. So that's question 2A. Go on to question 2B, where you'll see the baker's dozen subclass of the bagels order item.